Hi there, so this follow-up video is coming a bit later than I had anticipated, but that's fine. So, what I mentioned we were going to do is that we were going to go over the for each loop. So, I'll first create a new file to introduce the concept, and then we're going to come back and replace this loop with the for each loop. Okay. So here's a new class for each example. Public static void main, we'll create it. Okay, so let's go ahead and create a integer array. So int r is equal to, and then we'll just simply declare this array as is. Sorry, with we'll just create this array without literally right here. Okay, so just a bunch of numbers. Now, typically the way you iterate through an array is by going through the indices. We look at each index in the array. So if we're trying to sum up all the items in the array, we might go int sum is equal to 0, right? This is the classic running sum. For int I is equal to 0, where I represents the index. I is less than array.length, right? So I starts at index 0 and we go up to, but we do not include the length of the array, which means we go through indices, in this case 0, 1, 2, 3, 4, 5, 6, right? So this is a 7-item array, so we go up to, so we include index 6 but not index 7, then we increment to the next one. Okay, right, so we go through indices 0 to n minus 1 if the array is n long. Okay, so and then we get the item from that index. So int value is equal to ri, and then sum is equal to sum plus value, right? As opposed to I, we aren't adding the index, we are adding the value stored in that array, right? The value stored at that index. Okay? We can, of course, condense this a bit, right? We can replace this with plus equals value, if you remember, right? To increment sum by value. And then we can actually condense this even further because value is kind of unnecessary here. We can just increment by the value that's stored in the array at index I. Okay, so other than going through the array and grabbing the item at each index, we don't really care about what the index is. We only use it to access each item. And if that's the case, then you can use a for each loop instead. You use a for each loop when you don't care about what order you're going through all the items. You just want to make sure you go through all of them. You're going to go through all of them, and you really don't care how specifically. You might care how depending on what specific data structure you're using, but you're not going to go over every other one. If you're going to go over every other one, you need to go through them in a specific order, then you care about what the index is, right? If you're going over every other one, then you care, right? We need to grab each. If you care about grabbing every other item, like 2, 4, 6, and 3 in this example, then you care about what index we're storing our items at. Okay, but if you don't care, then you can use a for each loop. Now you can use a for each loop over basically anything that's iterable, anything that we can create an iterator for, which we'll go over in a bit. But I like to introduce, and for each loops typically get introduced there, but I like to introduce them early on because it provides a nice and easy way to go over stuff. It provides a much more elegant way to write things. So, and it looks like this. The format for each loop looks like this. Rather than the for loop we've been learning where we use the indices, it looks like this, right? It's got 3 parts separated by semicolons. The for each loop has 2 parts separated by a colon. Okay? And the way we can write this is for each int value, right? There's that value word again. Notice that I didn't put I there because I like to use I for indices. Int value, and we read this colon as in. So for each integer value in array. Now we put this int here to, this is a collection of integers, right? It's a bunch of integers just put together, right? Whereas this int, and so we're going through each individual int. So this is a bunch of integers. So therefore we have an int right here, right? A bunch of types over here, and the individual type over here, right? If this was an array of doubles instead of ints, we'd put a double here. So for each int value in array, sum plus equals value. It's a lot shorter, a lot cleaner, a lot more concise. Let's go ahead and prove that it works, because you really shouldn't accept that without proof. 27. Okay, so now let's go back over here and use that same kind of idea over here, where we're not summing them up. We're just telling each animal to move and eat. So here, right, I'm getting animal A out of this. I'm getting the animal at index I, and telling that animal to move and telling that animal to eat pizza, right? So instead, what am I going to do over here? Right? It's a for each loop. So zoo. So we're iterating over zoo. And what is zoo? It's a bunch of animals. So I'm going to put animal A over here. Instead, what I can do over here is now do animal A. For each animal A in the zoo, have that animal move and have that animal eat. And that animal runs the appropriate method for what type of animal it is. So that is the for each loop in a nutshell. It's very straightforward, very useful. And when we get to sets, it's really the only way you can go through sets to deal with, to get values out of it that are useful. Or to rather go through all the values in the set.